I have an extra piece ready. All right. And we are recording. Excellent. All right. So today we're continuing to look at box plots, okay? We're mainly focusing on box plots, but we're looking at a different aspect of it. We're looking at the measure of center. Now, the measure of center, so far with box plots, we've been finding that Q2 right in the middle, that's the median. But the measure of center can either be the median or the mean, okay? And it's based on if there are what are called outliers, okay? Anybody ever heard of Usain Bolt? He's the Jamaican sprinter. He's super, super fast, right? So if he came and he was helping to be a track coach with West Campus, if he raced the kids, he's going to beat everybody by so much. He's so fast, right? So an outlier is when one of the data points is so far above or below the center that it skews it. It makes it hard to draw conclusions because that one data point, that Usain Bolt's running with our, fresh JV team, the one outlier is going to make all the data skewed in one direction. Okay. It's just like when something's way faster, way quicker, way slower, it's going to mess up all the other data because, you can't tell the true measure of center if you have these outliers out there. But what we're going to do is we are going to decide which measure of center to use. It's either the mean, we'll use the mean, the average, if there's no outliers. We'll use the median if, yes, there are outliers. Okay? So those are the two options we're going to have. So the main thing to figure out is, are there outliers? Okay. Now I want you to, I'm going to say it again, outliers, the value is much more or less than the rest of the data. So an outlier would be like this. You see how we have the median in the middle here, Q1, Q3, but look at the max. The max value is way over here. It's way over here. And this is an outlier because it's so far away from the other group. Now we can see it on a graph. We could see it in a graph like this, but we actually have to know what is the cutoff. Where are the fences? Is the outliers where it's anything outside of my hands there? Is it anything outside here? Is it way out here? This is like the fence where anything on the outside is outliers. We need to figure out what is the actual value where outliers are going to begin. Where the number, if it's bigger than this certain value, it's going to be an outlier. Okay. I want you to think of it like this too. What we're trying to figure out with the outliers, here's our Q1, Q2, Q3, right? Everyone feeling good about this? Now, we're going to figure out right now that there's like an imaginary fence. The imaginary fence is a certain distance to the left of Q1, and anything outside there is our outlier area, okay? There is an imaginary fence here that is to the right of Q3, and anything out there is also an outlier. So what we're going to do is figure out where these like fences are, okay? Where the fences are, and they're a certain distance between or from Q1 and a certain distance to the right of Q3. But anything that goes beyond that is going to be an outlier. So if I ended up that I had a minimum value out here, right? Here's my minimum value of like 10. 10 would be an outlier, right? If I had a maximum value way over here, a maximum of 50, 50 would be an outlier, you see? So it's just going to be a matter of figuring out how far over we need to go from Q1 and how far over this direction we have to go from Q3. And that is the next part. Okay, we're figuring out where those fences are. Okay, so to find if you have an outlier, you have to first find the IQR. Okay, the IQR, remember, the IQR is just the distance between Q1 and Q3. IQR, interquartile range. So you find the IQR, you take the IQR, you multiply by 1.5 every time. This is like a formula. We do this every time. You multiply by the 1.5. So IQR, whatever, if that was like 4, you'd multiply 4 times 1.5. And then what we do is we take this distance, the IQR times 1.5, and we go from Q1 and we minus this IQR times 1.5. We minus it from Q1, and we add it to Q3. That gives us the distance to where these outlier fences are. Okay, so we find the IQR, check. We multiply it by 1.5, good. We move to the left of Q1, that distance, we find our fence. We go to Q3, we take IQR times 1.5, we get that distance and go to the right, and that is the outlier fence on that side, okay? So it's to the left and right of Q1 and Q3, as I just said. And you can see here's our fence, and we're going to just be going in each direction that same distance that we compute from the IQR. Okay. Now remember, if you have outliers, if your answer is yes, you have an outlier, then the median Q2 is the best measure of center. If you don't have outliers, remember what I said. If there's no outliers, then we have to find the mean, because the mean is the best measure of center. So we may end up with a situation where we have a measurement of Q2, which is our median, and we also have the mean as the measure of center, and we would mark that on our box plot. Okay. So what I'd like to do now is a example problem. It's in your book, workbook, but y'all don't have it yet. So I am going to have it handy here. Okay. So we're just going to be looking right now at the highlighted yellow bit. We'll maybe do the purple after this. Okay. So look, in this situation, Mr. Lamb's class, they're trying to find the expected length of any given pencil. Different students have different lengths of pencil. And for this one, we're only going to be looking at students 1 through 7. So with this, we need to make our box plot, because we're going to have to describe the shape, which is the measure of center, and how the spread is. Okay. So this is going to be accomplished through doing our box plot. Now, let's go ahead and do that. I need to first reorganize them from least to greatest. So here's my student. So go ahead and copy this with me, guys. You need a good example for this. Okay. So we're just going to make this into a box plot, find out where our outlier fence is, see if there's anything outside of the fence. All right, the lowest value here looks like student 6, 15.6. And then we're just gonna, nope, student 7. Whiteout tape, I got you again. Ha ha ha. All right, student 7. Student 7 is 10.2. Student 6 is 15.6. Looks like it kind of just goes down. Student 5, 16.1. Student 4, 16.5. Student 3, 16.7. Student 1, 17.8. And student 2, 19.0. So, I mean, it's a decent amount of writing, but it's not crazy. It's not so bad. All right. So, I mean, if it was English class, you'd be writing more. You'd be using your hand more. Okay. So no need to get worried about how much we're doing here. It's not too much, guys. All right. So we're going to make our box. Q1, Q2, Q3. We're going to figure out the IQR, okay, in order to figure out where these outlier fences are. Okay, that is going to be a distance from Q1 and Q3. And then after that, we'll put our minimum and our maximum to see if any values are on the outside of that. Okay. How many do we have? 1, 2, 3, 4, 5, 6, 7. That's nice of me. What a nice teacher. So look, the middle is Q2. That's our median, 16.5. All right. And then I look, and because an actual data point was the median, I just have to look at the data points below that and above it. I don't count that student 4 twice. If I included it in the lower and the upper, I would be counting it twice. We don't want that. So I just look at the data points that were not included. And I see here, this is obviously going to be Q1. This is going to be Q3. Why? Because it's what's in the middle. What's in the middle? There's 3. So what's in the middle? The second one. There's 3. What's in the middle? The second one. So it's always about what's in the middle. What's in the middle of the whole thing? What's in the middle of the lower? What's in the middle of the upper? And that gives us our 2 points here. 15.6, 17.8. Almost done. Let's see. What is our IQR? 17.8 minus 15.6, 2.2. Okay. So now we need to go in and use that IQR. Remember that to find the outlier distance, how far to get to these fences, we need to have IQR times 1.5. That's going to be our outlier distance. I'm even going to write that. Outlier distance. Whoops, I made it one word. It's a new word. It's called outlier distance. All right. And that's going to be 2.2 times 1.5. So let's do that. 2.2, whoops. 2.2 times 1.5 is 3.3. Okay. So this is the number we're going to use. And what we're going to do is go from Q1. We're going to go this direction. We're going to minus 3.3. From Q3, I'm going to go this direction. We're going to add 3.3. That's going to tell us the boundaries for the lower outlier. Whoops. And the, dang it, and the upper outlier. Quit moving the paper, Mr. Seals. All right, so let's do that. 15.6 minus 3. 15.6 minus 3.3. Give me a break. 15.6 minus 3.3. Please, the fifth time. All right, look. This outlier limit is at 12.3. I'm going to do the upper. 17.8 plus 3.3. This outlier limit is 21.1. Okay. Now we need to see if we have outliers. Now, any number value that is below 12.3, any number value that is greater than 21.1 is in outlier territory. So we need to see if we have any. Let's see. We have them in order, so it's easy to see. This one, this is an outlier. It's also the minimum. So let's put it over here. We're going to put it over here. It is an outlier. It ends up in the outlier territory. 10.2, it's our minimum. And this is our outlier. Yes, it has an outlier because it's on the wrong side of the fence. The other one, the greatest we have is 19, so that does not make it to the outlier territory. It's just our max. But our minimum is in outlier territory. Okay. So this is what we need to say. If we're describing the shape, here's the answers for this. We're going to write it right here. We're going to say, let's say contains outlier. The, what? 10.2 is less than 12.3. That's why. Right? If our lowest point was 15, it wouldn't be an outlier. If our lowest point was 12.5, it wouldn't be an outlier. If our lowest point was 12, yes, it would be an outlier territory. So 10.2 is our lowest value, and 10.2 is an outlier because it's less. It's on this side of the outlier territory. Just as in, if it was greater than 21.1, it would be an outlier territory. Okay. And I'm going to go ahead and say the measure of center is going to be, let's see, when we have an outlier, what do? If we have an outlier, then the measure of center is the median. And that's just our Q2. The other thing that we'll say is, as far as the spread of the data, the spread, because it's spread out so far and we have an outlier, remember when we were talking about spread, so I would just write spread, there's high variability or high variation. Variation, remember, is just how many different types of data points there are. And we have high variation because it's pretty dang spread out. It's spread out all the way from 10.2 all the way to 19. And our IQR is pretty small, but we still have a lot of points that 10.2 brings it to be high variation. And that is our assessment, and we're done with it. All right, guys, I can't see your videos, but I want you to give me a thumbs up, sideways down. In the chat, in the icon, wherever. It's not, give me some feedback. I need feedback. I need it. Let's see some more feedback. All right. Okay. Sideways. Okay. All right. That sounds like it's good, because I'm going to do one more example, and I'm going to do it a little bit cleaner. Okay. I'm going to let you take a screenshot if you need it for this. Okay. Take a screenshot. It's based on this data. All right. And then let's do one more. We're going to do the purple now. All right, first step always is to put it in order. We have the students and we have the length. So the student, the lowest measurement, it looks like these are almost in order. It's number 11. 11 is 14 centimeters. Then 12 is 14.3. And then the next is 13, it's 15.1. So keep up with me with this. We're just putting them in order. Whoops, 15.6. Let's see, 15.6. And then 16 is 16.1. 17 is 16.2. 18 is 16.2. And 14 is 17.3. All right, how many do we have? We had 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We got them. All right, tell me, why is this one slightly harder? Anybody know why this one's slightly harder? It's a little bit harder to find the median, and I want to see who has kind of depth, a little more depth of knowledge. Why is this one going to be a little bit harder? Anybody know? Why would this one be a little bit harder? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Thank you, Victor. There are an even number of students. So the median isn't going to be an actual it's not going to be one of our data values. Excellent. So I'm going to go ahead and make my box plot down here. Let's find the median. There's 8. So I'm going to go down 4, up 4. The median is between these two. This is where we find Q2. So whenever you have a number here and it's between two numbers, we need to take the average of them. 15.6 plus 16.1 divided by 2. And we have 15.85. That is our Q2. Okay. And now what I need to do is look at the lower half and the upper half, and I am going to find the middle values. What's in the middle? What's in the middle? That's all this box plot cares about. Those are the two middle parts from the top and bottom. Okay, because the point here, Q2, wasn't an actual data point, so we can use all of the data points below it and all the data points above it. So I need to find Q1 that's in between those two values. 14.3 plus 15.1 divided by 2, 14.7. And hey, guess what the average between 16.2 and 16.2 is? I better get my calculator out. 16.2, just kidding. It's 16.2, guys. If it's the same number, it's going to be the average between is the same exact number, 16.2. All right, now let's figure out our IQR. And it's no mystery. IQR is just how far to go from 14.7 to 16.2. So I'm going to go 16.2 minus 14.7, and I get 1.5. Ah, this is going to be a little bit weird because the IQR is 1.5. But we're trying to find the outlier distance. Remember the outlier distance? Remember I made it one word, so I'm going to keep with it. The outlier distance is equal to the IQR times 1.5. It's just a coincidence, guys. It's just a coincidence. The IQR is 1.5, and we have to then multiply it by 1.5. When we do that, we get 2.25. That is an important number. That is how far to the left. I didn't write it in. How far to the left of Q1 and how far to the right of Q3 we need to go in order to find our fence, our outlier fence. Anything on the outside of the fence is an outlier. So we got to go from here. We're going to minus 2.25, right? Because that's how you'd find how far over it is. This is 14.7. You can't add 2.25 to 14.7. That's moving this way. We need to see this direction, so we're minusing. And 16.2, I'm going to go ahead and make this plus 2.25. So let's see, where is this fence? Where is this fence? We're going to see where the fence ends up. All right, the fence is 14.7 minus 2.25, and we get here to 12.45. And then 16.2 plus 2.25, and we get here to 18.45. Okay? Remember, those are, it's almost like, you know, this is where you get like a home run if you're playing baseball and you hit it outside the outlier zone. If it goes into the outlier zone, it's out of the park. It's out of the park. It's outside of the typical data where it's all grouped. Okay, so now watch. We know where the outlier is. Any number below 12.45, so you know that's 12, that's 11, that's 10, that's so on. Any number greater than 18.45, that's 19, that's 20, ... right? Any numbers outside in those shaded areas are outliers. So let's go back to our main data here. What was our lowest? Our minimum, right, was 14. Tell me in the chat, is 14 an outlier? Yes or no? You can do thumbs up, thumbs down. Is 14 our minimum? Our minimum is 14, and now we're going to graph it on the box plot. Is 14 an outlier? Good, Nelson. Take a guess if you're not sure. Okay, Jacqueline. All right, let's look. 14 is right here. It is not an outlier. What the heck? Why isn't it an outlier? Because the outliers are this side of 12.45. 12, 10, or 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Those are outliers. Is 14 less than 12.45? Think about that. Is 14 less than 12.45? Nope. So our minimum did not end up in outlier territory. Okay. Here's our max. Here's our max. Is 17.3 an outlier? I want you to guess. I need you to guess, guys. Is 17.3 an outlier? Okay. 17.3. We just figured out that the fence, the fence is 18.45, and any number that's greater. So if my greatest value was 20, that would be an outlier. But my greatest value is only 17.3. Where does that go? It only goes to like here. So it is not an outlier. That part's a little confusing. I need to make sure everybody knows how to do that. So I'm going to make a, we're going to draw the conclusions now. No outliers. Okay. Measure of center. When there's no outliers, we're going to say it's the mean. And because there's no outliers, we can also say it has low variation. All right, we're going to play a game because there's still some people, this is our answer. There's still some people that are not 100% with is it an outlier or is it not. So this game is called Is It an Outlier? Here we go. I'm going to make up a fake, let me see if I can just do this like that. 3, 2, 3, let's make it 4. So let's go 6 and 10. All right, if these were my values, got it. 17.3 is less than 18.45. But think about what you're asking. You're asking, isn't 17.3 an outlier because it's less than 18.45? If that was the case, then everything would be an outlier. But no, outliers are from the median. They're a certain distance away and beyond. The outliers are here and beyond. The outliers from the center are, here's the fence, and it's all the numbers beyond. So 18.45, 19, 20, 21, 1,000, billion, trillion. Over here, 12.45, 12, 11, 10, 9, 8, 7, 6, 5, right? So yes, over on this side, the outliers are less than this wall, but we're talking about the outliers are a certain distance and beyond. So on this side, it's above that value. Does that help? I really want you to have that. Okay, so we're going to still play a game here. And we're going to do this 4, 5, 6. That's going to be 7. I don't care. Let's just make it. That's not even what I want to do. Dang it. Whiteout tape, I love you. All right, here we go. We have some outlier walls at 3. We have another outlier wall, we're going to say at 13. All right. Very easy game, guys. Very easy game. Everybody play. So get ready to put thumbs up, thumbs down, or in the chat, yes or no. All right, here is our outlier fence. It's this direction from 3 and that direction from 13. Is 15 an outlier? Is 15 an outlier? Is 15 an outlier in this situation? Good. Is 4 an outlier? 4 an outlier. Thank you for those responding. Wait, what does that mean, Jacqueline? I don't know what that means. You said both. Is 4 an outlier? Okay, good. Is 1 an outlier? Wait a minute. Somebody said yes. Somebody said yes, that 4 was an outlier. Are you changing it? Okay, I'm giving different numbers here. So sorry, we're going to go back to 4. Remember, outliers are out here. It's going to be 3, 2, 1, 0, -1, all that. Outliers out here. Okay. So I said, is 1 an outlier? Is 1 an outlier? 1 an outlier. Okay, good. Is 20 an outlier? Good. All right, you guys are great. Is 3 an outlier? Is 3 an outlier? That's a trickier one. It's on the fence. All right, that one's a little confusing. 3 is an outlier. It's 3 and below. 3 and below. We find the outliers at 3 and below. Is 13 an outlier? 13? Yeah. Boom, boom. We got it. And lastly, is 9 an outlier? Is 9 an outlier? 9? Nope. All right. We got like 100% after that. Thus concludes our game. Is it an outlier? Okay. All right, guys. Give me a thumbs up, thumbs down, thumbs sideways for the lesson. How you feeling? Good. Is anybody sideways? Tell me in the chat. All right. Up. One is up and the other sideways. Okay. So we're going to have next Wednesday to look over this. I want you to try to do them on your own. We got some good examples. I would take a screenshot. This breakdown of this data was probably a little bit better than the last one. Okay. So I want you to take a screenshot of this for sure if you had a sideways. Okay. And we're going to look over this on Wednesday. And then remember, next Friday is our review, and we'll focus on this and the MAD. Honestly, the mean absolute deviation is one topic that's tricky. And this topic is so related to just box plots that those are our two topics we have to look over. We have to look over these outliers because it has box plots involved. And we have the mean absolute deviation, our MAD topic. Okay, I'm going to go and stop the video. Thank you for all the comments and feedback.